Hello and welcome to today's lesson on manipulating means and standard deviations. Our objective for today, by the end of the lesson, I'll be able to manipulate mean values and standard deviations both with scale factors and with combining means and standard deviations. Okay, we're going to try to have a little fun with this lesson, make it, stats a little more meaningful than some of our other videos. Okay, so we've got a company, Tonka Toys. Okay, they're going to be a truck outfitter. They need to create a pricing structure for all of their modifications they do for Jeep Wranglers. Okay, so we're trying to change this basic box Wrangler into, the monster that we see on the right. Okay, so when we're going to look at their two most common products that this company would do, okay, they're going to do suspension lifts, wheels and tires. Okay, those always go together. And then we've got fender flares that they're going to pat on to the vehicle. Okay, we have to consider two things: time to complete the work and cost of products. Okay, what we want to understand, which of these two is truly a variable value? And the piece that is variable that we have to consider is the time to complete the work. Okay, the cost of the product is what it is. Now that might go up and down slightly, but from one job to the next, okay, that is usually not going to be our variable cost. You can get an upgrade, you can do some things, but the cost at each level is what it is. So we're going to look at the variability of the time to complete the jobs overall. Okay, so now, one thing we have to understand, no two of these projects, no matter how good the person working on the vehicle, is going to take the same amount of time. So if we look at the fender flares project, okay, that job has a mean value of 2 hours with a standard deviation of 0.5. So every time they go and they do fender flares, they know that it's going to take about 2 hours. Okay, give or take a little bit based on, sometimes, things just fit right, work right. The worker could just be in a groove doing things a little bit better. So we want to understand that the hours to complete the job is normally distributed. So if we look at this one, we've got our mean value of 2, standard deviation of a half hour going in either direction. So now, what happens if now there's a new part involved? Okay, that new part takes 0.5 of an hour longer. So what's going to happen to this distribution? So we know that the job is going to take 0.5 of an hour longer because of the introduction to this point. So what's going to happen to this distribution? The distribution is going to have to move up to match that time-wise. Okay, so this is when we're dealing with a constant value. Our mean value is 2.5. But notice, every one of these jobs ended up being a half hour longer. So if every job is a half hour longer, notice that the standard deviation didn't change. It's still 0.5 of an hour. Okay, so that's an important piece. What happens when we add a constant to a distribution? And we'll start using some symbol notation right now. So if we have a mu of x plus a constant, okay, all we do is we add those pieces out for the mean. But if we have standard deviation plus a constant, okay, the constant doesn't affect the spread, it only affects the standard deviation of the value. Okay, so let's take a look. Let's redo this notation here just slightly. Okay, so if we're trying to find the mean value of x plus a constant, that just equals the mean value of x plus the constant. But if we're looking for the standard deviation of x plus a constant, that just equals the standard deviation of x. Okay, so adding a constant to every value in the distribution doesn't make the distribution any wider, so that's why the standard deviation stays the same, okay, but it does move the mean value based on that constant. Okay, now let's look at multiples situation. Okay, so now the company just got an order for 5 jobs, and they need to figure out, okay, how much time do we have to allocate to do those 5 flare jobs? Okay, odds are a lot of you thought, okay, we look at our distribution that we have here, 2 hours for one job. We just multiply that out, and on average, it's going to take us 10 hours to complete that job. Okay, now, how about standard deviation? Okay, think about what's going to happen with the standard deviation here. We're going to do 5 of these 2-hour jobs. Okay, every job has its own standard deviation. As we build through, the one thing that we'll see is the standard deviation now increases based on that value. Okay, so if we're talking about a single situation, a scale factor of 5, a multiplier, has the exact same effect on the mean and standard deviation overall. So now if we're looking at our formulas here, if I have the mean value of, and we'll just use our value, 5x, so we've got 5 of these jobs equals 5 times the mean value of x. Same thing with standard deviation. Standard deviation of 5x, what we're doing is we're really stretching out this distribution because every time we can have a different situation involved here. So that equals 5 times the standard deviation of x. Okay, we're going to have to be careful with standard deviations as we move along because things don't always affect the standard deviation the same way. And we'll see that here in a second. Okay, now we were only looking at one of the 2 jobs. Now let's start putting these 2 pieces together. Okay, we have to look at combining the 2 jobs in time. We've got the suspension lift, okay, mean value of 10 hours, standard deviation of 1.5 hours. Okay, so let's call this mu x equals 10. And we've got standard deviation of x is 1.5. Okay, and we've got our fender flares. Okay, we're going to call the fender flare job with our mean of y. Okay, average time to complete that 2 hours. Standard deviation of y equals 0.5 of an hour. Okay, so now we've got these 2 to combine. Okay, and if we're going to combine these, what we want to do is look at some of our basic rules. Okay, so how do we combine them? If I want to combine the mean of x plus y, okay, we can actually do exactly what we see. The mean of x plus the mean of y. So if we're looking at our situation, we've got 10 hours plus 2 hours. Okay, that's going to give us a 12-hour average to complete the modification of one vehicle with suspension and tires and the fender flares. Okay, now the difficult part comes into play when we're trying to combine the standard deviation of x and y. Okay, it would be nice if we could combine those standard deviations and work from there, but we can't. what we actually have to do is turn them into variances. Okay, so we have to square the standard deviation of x, square the standard deviation of y. Okay, so now it's a variance, and then we can combine them. And then to finish that up, we have to turn it back into a standard deviation by square rooting that variance. Okay, so it is a fairly tedious process overall. Okay, and we're doing the square root of our x value 1.5 squared plus the standard deviation of 0.5 squared. Okay, and we're putting those together to get the value that we're looking for in this situation. Okay, just had to take a quick break there to pull up the graphing calculator here. Okay, so we're just going to run through and work with these values, finish up this piece. We've got 1.5 squared, squaring our standard deviation, plus our other standard deviation squared. So we have to square these values before we can combine them. Once we've combined them, then we can square root that answer and get our combined standard deviation. Okay, so it's not a simple addition. We can see that. It actually didn't grow much from the standard deviation of the one situation. Okay, but we have to consider that overall. Okay, now, what if we're doing a combination of 5 of each of these? So now we're putting these together. So we want the mean of 5x plus 5y. Okay, good news is in this situation, if you're dealing with mean values, you do exactly what you see. 5 times the mean of x plus 5 times the mean of y. And we can just add those values together to finish up. So we've got 5 times 10 is 50, plus 5 times 2 is 10. Okay, if they're doing 10 of these vehicles, they know on average it's going to take them 60 hours to complete that work. Now, if we're looking at standard deviation of 5x plus 5y, okay, how do we deal with that? We want to apply the scale factor to the standard deviation, but then we have to turn it into a variance. Okay, apply the scale factor to the standard deviation, turn it into a variance, and then to get it back to a standard deviation, we square root at that point. Okay, so we're working through dealing with that calculation. So we've got 5 times 1.5 quantity squared. Okay, that was the adjusted standard deviation. We're squaring that to turn it into a variance so we can add the values. And then we've got 5 times 0.5 quantity squared. Okay, there's our variance value, and then we're going to square root that to turn it into our combined standard deviation. So we've got 7.9 hours as our combined standard deviation. Now, we've got one thing left here. What happens with subtraction? Okay, if we're wanting to deal with subtraction here, so if we want to do the mean value of x minus y, okay, you can probably guess with mean values, we do exactly what we see. The mean value of x minus the mean value of y, and that gets us our answer. So for using our values that we had in the previous problem, 10 minus 2 equals 8. Okay, now standard deviation is the problem. Okay, think about what standard deviation it is. It's a measure of spread. Now, depending on the order of these two values, do you see how I can get a negative variance or a negative mean value? If I did 2 minus 10, I would get negative 8. Okay, now, can we have a negative spread value, a negative standard deviation? Okay, and the answer is no. So what we have to do is we have to look at this negative as a scale factor. So when we're looking at the scale factor, we are going to take the standard deviation of x, square it. We're going to take the negative standard deviation of y and square it. Okay, think about the benefit of that square on the minus. This turns it into a positive situation, and then we square root from there. Okay, so let's look and see how this happens with some actual values. Our standard deviation of x, 1.5 squared, plus negative 0.5. I attach the scale factor to the standard deviation, and then I square it. And then to turn it back into a standard deviation, we square root at that point. So let's run through and just do this calculation quick, and we'll see the benefit of this overall. So we've got 1.5 squared plus parenthesis negative 0.5, close the parenthesis and square it. Okay, so that squaring makes that value positive, and then we square root to finish. And you see, we got this answer once before. So x plus y, x minus y actually give us the same standard deviation. All right, and that's the end of our lesson. Okay, learning how to combine mean values, combine standard deviations. Have a good day.